Okay, so let's go to question B, finding the integrating factor of this differential equation. We go again step by step. You can see that because of it's not in the differential equation in the differential form. So first step we have to write in differential form. Differential form, which is dy over dx equal to x. Yeah. And then, or you can write it as x dy equal to x y power y is dx, and then rearrange in a differential form, which is just write like this. This means that I move this to another side. Okay, so you can get this a new equation a, which is this is n xy and this is n xy. Okay, so step 2, you have to check if it is exact. Check if it is exact by the partial differential equation of m over dy, which is the function of y is like this. And now you do the partial differential equation only just with respect to y. Okay, so you get the result is minus y plus 1. Okay, while the differential part, the partial different derivative of n respect to x is equal to how much x? Oh, it only equal to 1. It can be seen that partial derivative of m over partial is not equal to partial derivative of n respect to x. So it is not exact. It's not exact. So our next step is to check to find the integrating factor. Find integrating factor like this. And how do we find it? We observe that we have 3 cases, case 1, case 2, and case 3. But in this case, because of the partial derivative of m, it containing both x and y, so it should be going to case 3. Case 3, which is integrating factor have contained x and y together, which is equal to 1 over x multiplied by m minus y over n. Okay, you can see that this is m, which is this is the value of m and n. So you have to use this function. It's not the partial derivative. Okay, so it's become like this: 1 over x, and function m is minus x y squared plus y minus y multiplied by x. Okay, and it's equal to like this. Alright, so next step is convert. So our next step is convert equation A into exact by multiplying with indicating factor. Okay, so you can get that 1 over x y over s multiplied by our equation dx plus dy equal to 0. Okay, or you can multiply all and divide all the equation. You can get this. Dx plus, sorry, it's not plus, it's minus x over x y dy equal to 0, or again get a factor y x y over y like this. And now you can reduce the value of x. It became 1 over xy squared dy is equal to 0. And again you can reduce the y, and it became xy minus 1. Oh sorry, this is should be 1, right? 1 over x y dx minus xy squared over dy is equal to 0. It became a new equation b. So what you have to do is observe that what is a new n. This is a new n, and this is a new n. So the next step is you have to check if it is exact. Check again if it is exact by partial derivative again of m over dy, which is equal to xy minus over 1 and xy, which is equal to, this is the partial derivative, which you can observe that this is the f over g, alright? Derivative is equal to s g prime j minus f g prime over g squared. So we use this method, right? So we can get at xy minus 1 prime xy square minus xy minus 1, okay? And x squared over y prime over the function of like this. Alright, so u derivative of this y with respect to y, okay? So you can get it x and xy minus another function of derivative of y, so it can be like this. Okay, so the rest of the equations is became x power 3 over y and x3 power y plus x power 2 over x power 2, and you can write like this. You can observe that it's equal to 1 over x squared 2, alright, because it reduces like this, and you can reduce the power x, alright, so that is equal to derivative of m over y, alright. And let's check again of the power n over x, which is the function m equal to minus 1 over x squared, which we respect only to x, right, variable a. So it became 1 over x prime, which is equal to 1 over x power 2. Okay, so we can see that thus power derivative of y is equal to derivative of n over x. So it is exact. That's it. This is the solution.